NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics video, where we'll be looking at factoring expressions. We'll follow a step-by-step approach to simplify complex expressions by factoring them into products of simpler expressions. Let's start with our first example. We have the expression open parenthesis x squared plus 3x close parenthesis squared minus 2 times open parenthesis x squared plus 3x close parenthesis minus 8. Let's start solving this expression step by step. First, we'll rewrite this expression to reorganize the terms. We can express this as open parenthesis x squared plus 3x close parenthesis squared plus negative 2 times open parenthesis x squared plus 3x close parenthesis minus 8. In the next step, we'll expand negative 2 in the middle term. This gives us open parenthesis x squared plus 3x close parenthesis squared plus open parenthesis negative 4 plus 2 close parenthesis times open parenthesis x squared plus 3x close parenthesis plus open parenthesis negative 4 close parenthesis times 2. For step 3, we recognize a pattern that will help us factor this expression. We can rewrite this as open parenthesis x squared plus 3x close parenthesis minus 4 close bracket times open parenthesis x squared plus 3x close parenthesis plus 2 close bracket. In step 4, we'll simplify our expression by multiplying out the brackets. This gives us open parenthesis x squared plus 3x minus 4 close parenthesis times open parenthesis x squared plus 3x plus 2 close parenthesis. Finally, in step 5, we'll factor each of the quadratic expressions to get our complete factored form. This gives us the final answer. Open parenthesis x minus 1 close parenthesis times open parenthesis x plus 4 close parenthesis times open parenthesis x plus 1 close parenthesis times open parenthesis x plus 2 close parenthesis. Now, let's move on to our second example. Here we have a polynomial expression that we'll factor using a different approach. For our second example, we have x to the 7th power plus x to the 6th power plus x to the 5th power plus x to the 4th power plus x cubed plus x squared plus x plus 1. Let's work through this step by step. In the first step, we'll group the terms. We can rewrite this as open parenthesis x to the 7th power plus x to the 6th power plus x to the 5th power plus x to the 4th power close parenthesis plus open parenthesis x cubed plus x squared plus x plus 1 close parenthesis. In step 2, we'll factor out common terms from each group. This gives us x to the 4th power times open parenthesis x cubed plus x squared plus x plus 1 close parenthesis plus open parenthesis x cubed plus x squared plus x plus 1 close parenthesis. For our final step, we'll factor out the common expression from both terms. This gives us open parenthesis x cubed plus x squared plus x plus 1 close parenthesis times open parenthesis x to the 4th power plus 1 close parenthesis. Let's summarize what we've learned. In factoring complex expressions, we look for patterns that allow us to rewrite them as products of simpler expressions. Key strategies include grouping terms, factoring out common factors, and recognizing special patterns like the difference of squares or perfect square trinomials. With practice, you'll become more adept at identifying these patterns and applying the appropriate factoring techniques. Let's begin with our first example. We want to factorize the expression x squared minus 5x squared minus 36. For this problem, we'll use the difference of squares formula. Remember that a squared minus b squared equals a minus b times a plus b. Let's apply this formula to our expression. We can view this expression as a difference of squares, where a equals x squared minus 5x, and b equals 6. Next, we'll expand the brackets to simplify our expression. Now, we need to factorize each of these quadratic expressions. Let's start with x squared minus 5x minus 6. We're looking for two numbers that multiply to give negative 6 and add up to negative 5. Now we can substitute these factorizations back into our expression. And there we have it. We've completely factorized our original expression into 4 linear factors x plus 1, x minus 6, x minus 2, and x minus 3. Let's start with the expression we need to factor. We have x to the 4th plus 36 squared minus 25x squared times x to the 4th plus 36 plus 156x to the 4th. As a first step, let's rewrite this expression to better understand its structure. we have x to the fourth plus 36 squared plus the product of negative 25x squared and x to the fourth plus 36 plus 156x to the fourth. Next, we'll look at the term negative 25x squared. We can factor this as negative 13x squared minus 12x squared. So our expression becomes x to the fourth plus 36 squared plus the product of negative 13x squared minus 12x squared and x to the fourth plus 36 plus the product of negative 12x squared and negative 13x squared. Now, we'll use a clever grouping. We can write this as the product of x to the fourth plus 36 minus 12x squared and x to the fourth plus 36 minus 13x squared. Let's simplify each of these group terms. We get x to the fourth minus 12x squared plus 36 times x to the fourth minus 13x squared plus 36. Now we can recognize that each of these expressions can be factored further. The first expression x to the fourth minus 12x squared plus 36 can be rewritten as x squared minus 6 times x squared minus 6. Similarly, the second expression x to the fourth minus 13x squared plus 36 can be rewritten as x squared minus 4 times x squared minus 9. As a final step, we can factor these binomials even further. We get x squared minus 6 times x squared minus 6 times x squared minus 4 times x squared minus 9. Then we can use the difference of squares formula to get x squared minus 6 times x squared minus 6 times x minus 2 times x plus 2 times x minus 3 times x plus 3. We need to factor the following expression x squared minus 3x, quantity squared, minus 14 times x squared minus 3x plus 40. Let's start by rewriting this expression. We'll use a substitution to make this problem easier to handle. Let's set u equal to x squared minus 3x. This allows us to rewrite the original expression as u squared minus 14u plus 40. For step 2, we need to recognize that our expression is now a standard quadratic in u. We can rewrite this as u squared minus 14u plus 40. Next, we'll rearrange this to u squared plus negative 14u plus 40. Looking at this form, we need to find two numbers that multiply to give 40 and add up to negative 14. In step 3, we need to find the values that work in our quadratic. We need two numbers that multiply to give 40 and add up to negative 14. These numbers are negative 10 and negative 4, since negative 10 times negative 4 equals 40, and negative 10 plus negative 4 equals negative 14. Now for step 4, we can factor our quadratic in u. This gives us u minus 10 times u minus 4. Now we substitute back x squared minus 3x for u, which gives us x squared minus 3x minus 10 times x squared minus 3x minus 4. For step 5, we need to further factor each of these expressions. Let's start with x squared minus 3x minus 10. This can be factored as x minus 5 times x plus 2. Next, we factor x squared minus 3x minus 4 as x plus 1 times x minus 4. Finally, in our last step, we can write out the complete factorization. The original expression, x squared minus 3x, quantity squared, minus 14 times x squared minus 3x, plus 40, equals x minus 5 times x plus 2 times x plus 1 times x minus 4. Let's start with our expression. We have x plus 1, x plus 2, x plus 3, x plus 4, 24. We'll expand this expression step by step. First, we need to consider the highest degree term, which is x to the power of 4. This comes from multiplying the x term from each bracket. So we have x times x times x times x, which gives us x to the power of 4. Next, we'll find the coefficient of x cubed. This comes from taking the x term from 3 of the brackets and the constant term from 1 bracket, then adding all possible combinations. We get 1 times x times x times x, plus 2 times x times x times x, plus 3 times x times x times x, plus 4 times x times x times x. This gives us 1 plus 2 plus 3 plus 4 times x cubed, which equals 10x cubed. For the x squared term, we need to consider all the ways to get x squared by selecting the x term from exactly 2 brackets and the constant terms from the other 2 brackets. This gives us 1, 2, plus 1, 3, plus 1, 4, plus 2, 3, plus 2, 4, plus 3, 4 times x squared. Let's calculate. 2 plus 3 plus 4 plus 6 plus 8 plus 12 is equal to 35. So we have 35x squared. For the x term, we need to consider all the ways to get x by selecting the x term from exactly one bracket and the constant terms from the other three brackets. This gives us 1, 2, 3, plus 1, 2, 4, plus 1, 3, 4, plus 2, 3, 4 times x. Let's calculate. 6 plus 8 plus 12 plus 24 is equal to 50. So we have 50x. For the constant term, we multiply all the constant terms from each bracket. This gives us 1 by 2 by 3 times 4 equals 24. Finally, we need to subtract 24 as specified in the original expression. So we have minus 24. Now, let's combine all these terms to get our expanded expression. We have x to the power of 4 plus 10x cubed plus 35x squared plus 50x plus 24 minus 24. The constant terms 24 and negative 24 cancel out, giving us our final expression. Our expanded polynomial is x to the power of 4 plus 10x cubed plus 35x squared plus 50x. We can further simplify this expression by factoring out x. This gives us x times the quantity, x cubed plus 10x squared plus 35x plus 50. Let's look at an example. We need to factor the polynomial x cubed plus 3x squared plus 5x plus 6. Let's start by grouping the terms to make factoring easier. We'll rewrite the expression as x cubed plus parenthesis 2x squared plus x squared close parenthesis plus 5x plus 6. Now, let's rewrite this as x cubed plus parenthesis 2x squared plus x squared close parenthesis plus 5x plus 6. Oh, I see, I made a mistake in the grouping. Let me correct this. The original expression is x cubed plus 3x squared plus 5x plus 6. We can rewrite this as x cubed plus 2x squared plus x squared plus 5x plus 6. This allows us to group the terms more effectively. Following our example image, we'll group the terms in a specific way. We'll write this as x cubed plus 2x squared plus parenthesis x squared plus 5x plus 6 close parenthesis. From each group, we can factor out common terms. From the first group, we can factor out x squared, giving us x squared times open parenthesis x plus 2 close parenthesis. We keep the second group as is for now, open parenthesis x squared plus 5x plus 6 close parenthesis. Now, let's factor the trinomial in the second group, x squared plus 5x plus 6. This can be factored as open parenthesis x plus 2 close parenthesis times open parenthesis x plus 3 close parenthesis. So our expression becomes x squared times open parenthesis x plus 2 close parenthesis plus open parenthesis x plus 2 close parenthesis times open parenthesis x plus 3 close parenthesis. Looking at our expression, we notice that open parenthesis x plus 2 close parenthesis is a common factor in both terms. We can factor this out, so we get open parenthesis x plus 2 close parenthesis times open bracket x squared plus open parenthesis x plus 3 close parenthesis close bracket. Let's simplify the expression inside the bracket. We have x squared plus x plus 3. So our factored form becomes open parenthesis x plus 2 close parenthesis times open parenthesis x squared plus x plus 3 close parenthesis. Welcome to this lesson on polynomial factoring. Today, we'll learn how to factor a polynomial expression by grouping terms strategically. Let's look at our example. We want to factor the following expression: x to the fourth power plus x cubed plus x squared plus 4x plus 3. The first step in our factoring process is to group the terms. We'll group the first two terms together and the last three terms together. This gives us x to the fourth plus x cubed plus x squared plus 4x plus 3. In the next step, we'll factor out common terms from each group. From the first group, we can factor out x cubed, giving us x cubed times the quantity x plus 1. From the second group, we can factor out x plus 1, giving us the quantity x plus 1 times the quantity x plus 3. Now we notice that both terms have a common factor of x plus 1, so we can factor out x plus 1 from the entire expression. This gives us x plus 1 times the quantity x cubed plus x plus 3. Let's look at our example. We need to factor the expression 5x squared minus 40x plus 75. The first step is to identify if there is a greatest common factor, or GCF, that we can factor out from all terms. Looking at our terms, we have 5x squared, negative 40x, and positive 75. The greatest common factor of these terms is 5. So we can factor out 5 from each term. Now we need to factor the trinomial inside the parentheses x squared minus 8x plus 15. To factor this trinomial, we need to find two numbers that multiply to give 15 and add up to negative 8. The factors of 15 are 1 and 15 and 3 and 5. Let's check. Negative 3 and negative 5 multiply to give 15, and they add up to negative 8. So we can write our expression as x minus 3 times x minus 5. Finally, we can combine our results to write the complete factored form of the original expression. Since we factored out 5 in the first step, and then factored the trinomial as x minus 3 times x minus 5, our final answer is 5 times x minus 3 times x minus 5. Let's look at our example. We want to factor the expression 50x squared plus 30x y minus 56y squared. The first step in our factoring process is to identify and factor out the greatest common factor, or GCF. Let's look at each term. 50x squared, 30xy, and negative 56y squared. The greatest common factor of 50, 30, and 56 is 2. So we factor out 2 from each term, giving us 25x squared plus 15x y minus 28y squared. Now, for step 2, we'll rewrite the first term as a perfect square. 25x squared can be written as 5x quantity squared. We'll also rewrite the middle term 15x y as 3y times 5x. This gives us 5x quantity squared plus 3y times 5x minus 28y squared. For step 3, we need to split the middle term in a way that helps us factor by grouping. We need to find two values that multiply to give us negative 28y squared and add up to 3y times 5x. The values 7y and negative 4y work because 7y times negative 4y equals negative 28y squared, and 7y plus negative 4y equals 3y. So we can rewrite our expression as 5x quantity squared plus the term 7y minus 4y times 5x plus 7y times negative 4y. For the final step, we'll use the factor by grouping method. First, let's rearrange the terms to make grouping clearer. We have 5x quantity squared plus 7y times 5x minus 4y times 5x plus 7y times negative 4y. From the first two terms, we can factor out 5x, giving us 5x times 5x plus 7y. From the last two terms, we can factor out negative 4y, giving us negative 4y times 5x plus 7y. Notice that both groups contain the same binomial factor, 5x plus 7y. So we can factor that out, giving us 5x plus 7y times 5x minus 4y. Don't forget to include the common factor of 2 that we factored out in step 1. Our final answer is 2 times 5x plus 7y times 5x minus 4y. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.